We are now in Unit 5, dealing with polynomial functions. Today's topic is monomials. If you want to write that there, you can. Okay, monomials. A monomial is a number, variable, or a product of numbers and variables. So let's give an example of all three of those. First of all, you can have a number. So an example of a monomial is 5. You can have a variable. That example is y. Or a product of numbers and variables. So something like 10x squared. Okay, what a monomial can't be is like 5 plus x. That would be 2 terms. We're talking about just one here. That's what mono means. Okay, and when we simplify monomials, we're going to use exponent rules. Okay, exponent rules. And we're going to go back over what those are. So the product rule means when you're multiplying monomials, that's what a product is. So something like a to the m times a to the n. What would that end up being? For product rule, you're going to add m plus n. So it'd be a to the m plus n. You add the exponents. And one example we know well is x times x equals x squared. We all know that. We've been doing that. But why is that? Because this is really x to the first and x to the first. So if we add those together, that'll give you x squared. Okay, that's a product rule. Power rule is when you're raising something. A power means an exponent. So when we take something and raise it to another exponent, so a to the m to the n. When you do that, you multiply. So it'd be a to the m times n. Okay, let's do an example. A, m, and n are all the variables and numbers. So here's an example that follows that pattern. X squared to the 7th. What if you were given that? It would be x to the 14th. You're just gonna multiply them. Okay, cool. Quotient rule means to divide. So what if I'm given a to the m over a to the n? You're going to subtract the top minus the bottom. So a to the m minus n. That's your quotient rule. And maybe write that out. Top minus bottom. You don't want to go backwards. Okay. Top exponent minus bottom exponent. So what if you're given x to the 14th over x to the 3rd? This would be x to the 11th. Okay, and real quick, I want to show you why that works. So if the quotient rule was x to the 14th, I would have 14 x's. Okay, I just drew 14 x's out. And what if I had x to the 3rd on the bottom? I would have 3 x's. Okay, so what would this end up being? Well, 3 of my x's would cancel. And how many do I have left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that's a drawn out example of why the quotient rule works. And you could actually draw all of these out and see for yourself why the rules work. They always do. Okay, the negative exponent rule is kind of a rule of math. We can't have a negative exponent in our answer. So if you're given something like a to the negative m, this would be 1 over a to the m. So you kind of create a fraction if it's not there already and move it to the other side of the fraction and make it positive, okay? So let's say move sides, make positive. Okay, you're gonna move the side of the fraction, make it positive. So here's an example. What if you're given x to the negative 2? Well, make a fraction. This stays on the top, or this is the top, because that would be x to the -2/1. So we're going to move it down to the other side and make it positive. Then, what do we put on the top when there's nothing? A 1. So that ends up being 1/x². Okay, and you don't want to leave a negative in your answer, a negative exponent. Always need to change it using the negative exponent rule. Okay, and last thing is the 0 exponent rule, and that states a to the 0 equals 1. A is anything, so anything to the 0 power equals 1. Okay, 7x² to the 0 power, that's 1. Okay, the only thing that wouldn't work is 0 to the 0. We have no answer for that. That does not equal 1. That's undefined. There's no value. Okay, so as long as a is not 0, it will give you 1 when you raise it to the 0. Okay, so when adding or subtracting monomials, you just combine like terms. We'll get to that on the back. No, we have a couple here. So combined like terms means they have to be exactly the same, right? Like terms have same variables, same power. Same power matters, okay? So I can't combine 3ab² with 3a²b. Can't combine those because they have to have the same exact power. B would have to be squared, not A. Okay, cannot do that. All right, that's an example there. So number 1, we're asked to multiply. So what you're gonna do is the numbers aren't gonna change. Those numbers are always following the same rules. No matter what, I can do 5 times -7 and get -35. Okay? But for x's, this is a times, so we're gonna use the product rule. That would be x to the 2 plus 6. So my final answer there would be -35 x to the 8th. Okay? So you treat the numbers the same you always would, and the variables you use one of your rules here for exponents. Okay, number 2. Number 2, we have to do a PEMDAS. So we've got to distribute that squared to everything. So it'd be -2² a to the 3 times 2b², okay? And then we'll worry about the 8ab9 after. Okay, and so what I did here, when I squared it, is I did a power rule. So a to the 3 times 2, that's your power rule there. You don't want to add them because they weren't multiplied. It was a power to a power. Okay, so this would give me 4 a to the 6 b² times 8, and I'm going to go ahead and put a to the 1st there, b to the 9th. Okay, now this looks like what we just had before. I'm going to do 4 times 8, and then I'm going to add the exponents of the like terms. So 4 times 8 gives me 32. For my a's, I had 6 over here plus 1 over there. 7. B to the 2 plus 9, 11. Okay? All right. Number 3. So I'm going to divide the numbers, and then I'm dividing m and n separately by subtracting. So I'm going to go ahead and put into the first on the bottom. All right, we've got to do PEMDAS again. We're going to divide before we subtract. So 54 divided by 3 gives me 18. Then I'm doing top minus bottom. So m to the 6 minus 2, n to the 4 minus 1. You obviously do not have to write this middle step out. I'm just showing you how the quotient rule works, top minus bottom. So that would give me 18m to the 4th into the 3rd, and then we're subtracting 10m to the 4th into the 3rd. Okay, and let me ask you, can we do that? Can we actually subtract there? Well, remember, like terms have to have the same variables with the same exact power. And since m to the 4th is the same and n to the 3rd is the same, we can. Okay, so let's say m to the 4th and to the 3rd is just like a chocolate bar. If I had 18 chocolate bars and I ate 10 of them, how many would I have left? I'd have 8 chocolate bars. Okay, so 8, and I still have the same chocolate bars, okay? M to the 4th, n to the 3rd does not change. That stays the same. Okay, number 4. This has a negative exponent. So what I'm first gonna do is multiply the numbers, and then I'm gonna do my product rule there and add or subtract the exponents, and then we'll see what happens. So 2 times 10 will give me 20, k to the 4 plus negative 7. So this is 20 k to the negative 3. Okay, when that happens, you cannot have a negative in your answer. So what you have to do is create a fraction, and you need to move anything with a negative exponent to the other side, in this case the bottom, and make it positive, okay? So that's your answer there. 20 over k to the 3rd. Can't have a negative in my answer. Negative exponent. Cool, moving on. So number 5, I have to distribute the 2, the squared, then times. So PEMDAS still holds, E before M. Okay, when I do 2/3 squared, it's the whole thing squared, then r to the 2 times 2, s to the 7 times 2. Let's deal with that first, and then we'll times it by the other monomial. 2/3 squared means square the top and square the bottom. That's 4 over 9. If you're not sure, use your calculator. R to the 4th, s to the 14th. Okay? Then I still have times 1 over 6, r to the 3rd, and I'm going to put s to the 1st. Okay, so I'm going to times those numbers together, 4/9 times 1/6, and then I'm going to add the exponents of the common terms, okay? So 4 over 9 times 1 over 6, that'd be 4 over 54. Hold on one sec. That's 2, that's 3. So 2 over 27. Okay, 2 over 27. Then r to the 4 plus 3, r to the 7, s to the 14 plus 1, s to the 15. Okay? And so you can write this as 2 over 27, or you could have written this as 2r to the 7th, s to the 15th, all over 27. Either way. Okay, so what's going to happen with 6? When we have -1 power, the easiest way to think about this is that becomes a reciprocal. Anything to the -1 power, I can just flip it around and I will have the same thing. I mean, I'll have it flipped, but the -1 will go away. So this is equivalent to saying 7w to the 3rd over 14w to the 12th. And that way, I don't have to distribute the negative to everything, okay? So let's do that first. Then we're going to reduce 7 over 14. That's my number. And then we're going to take top minus bottom. Okay, so this will be 1/2 w to the 3 minus 12, which is w to the -9. So how do I end up getting this? Well, I already have the 1/2. This time we already have a fraction created. So it makes it a little bit easier. I don't have to make a fraction. But the W needs to go down to the bottom and become positive. Okay, so this is 1 over 2W to the 9th. All right, 17, let's try that quickly. 17, 15 over 24, or reduce that. 3 goes into both, so that gives me 5 over 8. Okay, then we're gonna take x to the top minus bottom. That would be x to the negative 2. So where does that need to go? It needs to go down here and become positive. Okay, that's my x's. Then my y's would be y to the 4 minus 3. That's y to the 1, or y. This is a negative, so I'm going to keep it on the top, y. That's another way you can do it, okay? Split them off separately and then decide, do they need to go up here or down here? Okay? If you didn't like that way, then you need to do it the way we did number 6. All right, 8. PEMDAS means distribute the exponents before you multiply things. So this would be c to the 4th over c to the 2 times 4, 8. Okay, times, this is negative 3 to the 4th, c to the 4th. Okay, if you have a parentheses, you keep the parentheses when you distribute the exponent, okay? If it starts in parentheses, you need to keep it in parentheses. If you got a negative answer here, you would be wrong. Okay, so what do I get now? Let's make this a big fraction. I would have negative 3 to the 4th, that's 81, okay, over, sorry, 81, and then I have c to the 4 plus 4, c to the 8th, over c to the 8th. Okay, what happens? Those c to the 8ths cancel. And so all we're left with is just 81. That's it. Those cancel, 81. That's it for the first page.